So, welcome to the another session of mathematics, and we'll begin from question number 25. Let's go. So, we have a function f of x is given to be 10 to the power 10x, and then we have g also. So, g of x is log x over 10 to the base 10. And then h1 is given to be g of f of x. So, h1 of x is given to be g of f of x. We'll immediately find out. So, g of f of x is going to be log to the base 10 here, and then f of x by 10. So this turns out to be log to the base 10 here, f of x, and then minus 1 politely. And this will be log base 10 here, f of x is given to be 10 to the power 10x. So luckily we are getting here 10x minus 1. So this is my h1 of x. Now what's next is hn of x is given to be h1 of hn minus 1, and this starts from 2, which means if I find out h2 of x, then I'll be writing here h1 of x. So it starts from 2, and then h3 will be simply h1 into h2 of x, and this iteration would go away. And let's go ahead. So if I try to find out h2 of x, then this would become h1 of, what is h1 of x? It is simply 10x minus 1. So let's again plug in. So 10 times 10x minus 1, and then minus 1 will give me 10 square x minus 11. So this is my h2 of x. Now if I find out h3, so h3 of x will be h1 of h2 of x, which means h1 of h2 is 10 square x minus 11 will give me h1. So this 10 will be here, and then we get here 10 square x minus 11 minus 1. So this will give me 10 cube x minus 100 into 10 is 110 minus 11 is 111. So this is my h3 of x. So now we see, we observe a pattern that this 10 to the power will be exactly whatever iteration we do here. So if it's saying h4, then this is going to be 10 to the power 4. And this 1 is 3 times here. Here for 2 we have here 2 times, and for 1 we have only 1 time. That means if I generalize hn, so my hn should look like this. Hn of x would be 10 to the power nx minus 1, 1, 1, 1, 1, 1, 1, like this, n times. So this is going to be my hn. Now what is required is integration. The in is equal to minus 1 to 1. So in is equal to minus 1 to 1 hn of x minus hn plus 1 of x. So let's write down here. So I get here hn plus 1 of x. That means I'll be having here minus 1 to 1. Hn of x is 10 to the power nx minus 1, 1, 1, 1, 1, 1. This will be n times. So this is my hn, and when I'll do hn plus 1, then I'll be writing here 10 times 10 power n plus 1x minus, and then 1, 1, 1, 1, 1, 1. This will be n plus 1 times. Now let's see. So this would be nothing but simply minus 1 to 1, and then 10 to the power n x minus 10 to the power n plus 1 of x. So this is minus, and then this will be plus and then minus. So from n plus 1 times, we are subtracting n times, which means like this. From 11, if I subtract 1, I'm going to get here 10. So from 1, 1, 1, if I subtract 1, 1, 1, I'm going to get here 1000. So this is going to be what? This is n plus 1. That means if I subtract, I get basically n. So this will give me again plus 10 to the power n. This minus this is going to be 10 to the power n. Now we need to integrate this. So if I integrate this, let's see what do we get. So this thing will turn out to be minus 1 to 1 10 to the power nx. Okay, x is at the bottom, and this is an odd function. So basically this becomes 0, and this also becomes 0. We are left with 10 to the power n, integration from minus 1 to 1, which is 2 times 10 to the power n. So I get 2 times 10 to the power n simply. So now we need to go ahead with the next part, which is summation. So that means now in sigma from n is equal to 1 to, this is given to be 2026. So let's go ahead with 2026 in. So I'll be having sigma n is equal to 1 to 2026. This 2 will be out here, and then I get here 10 to the power n, which is simply a GB. So this will be 2 and then 10 to the power n. It's like this, 10 plus 10 square plus 10 cube and so on upon 10 to the power 2026. So 2 will be here only. And then A is 10 into R. Common ratio is 10 again. So it will be 10 to the power 2026 terms minus 1 upon 10 minus 1. A to R power n minus 1 upon R minus 1. So I get basically 20 over 9 into 10 to the power 2026 minus 1. And that's the final answer for this. Move to the next part. Next part 26. Let's go ahead. I2n is given to be this and I2 is given to be this. So we need 4I2 plus I4n, 4I2 plus I4n plus 2. And the same thing. That means we need to find out I2 plus I4n and I2 plus 4n plus 2. So two things we need to solve. Okay. Let's go ahead. So I'll consider first I2 itself. So I2 is equal to integral 2026 to 4052. I have here a log of, this is root 2 over 2x the whole square. And if I perform the basic operation, so I'm going to have here 2026 to 4052. Rather, I'll choose it writing alpha and some other number, because every time writing this 2026 and 4052 is not feasible. Let's say this is my alpha, so this is 2 alpha. Of course, we see the difference that this is exactly double. So I'll take some limit. So that means I'm going to have here I2 is equal to alpha to 2 alpha. This is log of root 2, which we can write down log 2 power half, and then here 2x, and then this being whole squared. So this one would be written as alpha to 2 alpha. This half would be coming down by using the property of log, and then half will be simply squared here. And then I'm left with log 2 over 2x, and the base power is 2dx. So I get here 1 over 4. This 4 I'll be taking here. So I'm having 4I2. So 4I2 is equal to integral alpha to 2 alpha log 2 base 2x, which can be written as log 2 base 2x the whole square dx. I'll call this one here because I think this is quite simplified. So let's see here. Now what do we get? I think writing this won't be good because we did not simplify it all. This we'll go ahead one more step. So I'll go because I feel that this still can be simplified by using the change of base. So if we write it that way, then I'm going to have here log 2 over, this one can be written as log 2 plus log x the whole square dx. So log 2 over log x plus whole square, this now I can write down alpha to 2 alpha. Okay. So I'll consider dividing by, wait a second, let's see what is this base here, log 2 base x. So 2 base x, that means I should divide with respect to x the whole square. So I'll be having here log 2 base x the whole square, and this will give me 1 plus log 2 base x the whole square. This is what I'm going to get. So all I wanted is in this format, because we need to compare them. This is square 2x and this is base x. So I wanted in this format, so we got it. Now let's go ahead and play with I4n and then see what do we get here. This is I4n. Yeah. And I4n, when I write down, so I'll be having again limit is same thing, alpha to 2 alpha. So let's write down here alpha to 2 alpha, and then I4n. So when I have here 2n, this is minus 1 power n. So if I write down here I4n, then this will be 2n. So that means it is plus basically. So I'll be having 1 plus 2 times. So this will be 1 plus 2 times log 2 base x. Log 2 base x, this over I have here 1 plus log 2 over x. So 1 plus log 2 over x, the whole squared is already. Yes. Now let's go ahead. So alpha to 2 alpha. Now this looks like I have here 1 plus 2 log 2 base x. So it means if I add and subtract this guy, log 2 over x, the whole square, and then again log 2 over x, the whole square. So if I do this addition and subtraction, then denominator looks a bit familiar because they share the close relation with 1 plus log 2 over x, the whole square. I can now simplify and write down simply alpha to 2 alpha, and this will be 1 minus log 2 base x over 1 plus log 2 base x, the whole square dx. Now if I integrate this, I get here alpha minus alpha to 2 alpha log 2 base x, and then 1 plus log 2 base x square dx, which means I have now written I4n is equal to alpha minus, this is nothing but 4I2. So we got I4n plus 4I2 is equal to this, which means I can now write down I4n plus 4I2 is equal to alpha. So alpha is 2026. Yes. While starting the problem, only we take n. So this is going to give me 2026. And that will make my option C correct. A is therefore wrong. A is therefore now wrong. And now we will go and find out I4n plus 2. So let's find out I4n plus 2 here. So I4n plus 2 will give me where do I write it? Okay, so I'll write it here itself. What does I4n means here in this regard? I'll take it some other page. So I4n plus 2 will be equal to what? So if you consider this thing, okay, I4n plus 2. So I4n I already have. I4n is nothing but, just see. So if I plug in n is equal to 1, I'm going to get here minus. So for n is equal to 2, I get here 4, which is again 2. That means plus. So when I write down I4n plus 2, and if I plug in here n is equal to 1, so I get 6. So when I get 6 here, then I6 I'll be getting only when I write down 3. So which is going to be what here? Minus. So this time it is going to be alpha to 2 alpha. This is going to be 1 minus 2 times log 2 base x over 1 plus log 2 over x the whole square. So now at this portion, we now have to reduce it, and we don't have to solve it. We need to convert into some other form. So let's see up to where we can go. It's log 2 base x square dx. This is my I4n plus 2. Let's consider this thing. So I4n plus 2 is here. Now let's go and simplify. So if we consider alpha to 2 alpha here and then 1 minus 2 log 2 base x, then this is exactly same. So 1 minus 2 log 2 base x, again we'll perform the same cassette. So plus log 2 base x square added and then subtracted also. So log 2 base x the whole square. So now we are going to have it here like this. This over 1 plus log 2 base x the whole square. Now this will be now split up to write down alpha to 2 alpha, and this is 1 minus log 2 base x square over 1 plus log 2 base x square. This thing, and then minus again integral alpha to 2 alpha log 2 base x over 1 plus log 2 base x square dx. No, this is being squared again. So this looks familiar. This is nothing but 4i2 alpha to 2 alpha log 2x and this thing. So I can now write down this thing as this limit itself alpha to 2 alpha, and then I'll be having here 1 minus log 2 base x over 1 plus log 2 base x the whole square dx minus 4 times I2. This is my I 4n plus 2. So we can now write down I 4n plus 2 is equal to, so I 4n plus 2 plus 4I2 is equal to alpha to 2 alpha. We now have 1 minus log 2 base x. So 1 minus log 2 base x over 1 plus log 2 base x the whole square dx. This will be further written as alpha to 2 alpha. This now we can write down using the change of base theorem, or so the property of log. This 1 minus log 2 over x. This 1 can be written as log 2 base 2. So we can write like this log 2 base 2 minus log 2 base x, and then here again log 2 base 2 plus log 2 base x squared. And then this would be alpha to 2 alpha. I can have it here log 2 over x, this thing, and then again log, I should have written here x based, in fact, because the base is x here in the denominator. Same thing here also. Mhm. Base x is so log x base x will do the job here and here also. So I can have here log x, and then this will be what? X by 2, and then here log again x, and then 2x. Now, if we see the bases are same here, that means we can again combine the base, and then I can have here log of x over 2, and then base is 2x. I get this. And this is being squared. That. So any option do we have like this? Log 2x base x we have. X by 4. I think no option. Log x by 2 here. Okay, so we need to make the substitution. So what we will do, we'll make the substitution. Since we want the base to be simplified, so I'll take 2x is equal to some t. So let 2x is equal to t. So this implies dx will be half of dt. So now my integration will be transformed into, instead of this is 2x, so when my x is alpha and 2 alpha, they will now be changed to 2 alpha and 4 alpha. So this will be 2 alpha and 4 alpha, and log is being squared. This is half of, and then dt here, and we have taken 2x as t, so x will be t by 2, means I get here t by 4. So I get t by 4 here, and then 2x is t, and this will be t itself. So this thing further can be written as log square. I'll interchange just because we need here x in that function. That's it. So let us see if something is looking like this. Oh my God. I think this one works. X over 4x and then log 4 square. This is 4 alpha. So yes, this is being double and this is being 4 times. So B is the correct option. So B and C are the correct options. Now moving to the next question. We need the value of integral 0 to 1 e to the power square root of e to the power x plus half of e to the power root of e, and then to the e, and then ln of 1 over ln of x to the power lambda dx, and lambda is this limit. So let's consider this limit only first. So lambda is equal to limit x tends to 0. We have x to the power 2026 factorial over 1 over x to the power 2026 factorial, and this is GIF. So of course we can use the sandwich rule for this. So GIF is sandwiched between 1 over x to the power 2026 factorial minus 1 is less than GIF of 1 over x to the power 2026 factorial is less than the same guy, x to the power 2026 factorial. So now I'll multiply by x to the power 2026 factorial. So if I multiply, I get here that's factorial. This is less than or equal to x to the power 2026 factorial into 1 x to the power 2026 factorial. So this will give me 1 minus x to the power 2026 factorial is less than the question which we are supposed to solve. So if I take the limit as x tends to 0, I get here 1. So lambda is equal to 1 by sandwich rule. Lambda is 1, so we don't have to worry about it. So I'll simply remove this. Now the question has turned to this. Now this also we can further write down 0 to 1, and then e to the power root of e to the power x plus 1 over t. This ln of 1 over can be written as minus ln of. That means I'll remove this half, and I'll write down minus half. So minus half of integral e to the power root e into e, and then ln of x dx. This could be further written as 0 to 1, e to the power e power x, and then this minus, I can flip it again, write down e to e root e, and then ln of x dx. So now if we look at this function and look at this function, then they share a close bond again. So if I consider f of x is equal to e to the power root of e to the power x, this is my y basically. And now I take log. So ln y is equal to root of e to the power x, and this is root half. So I'll square it. So ln y will be ln y square would be e to the power x. Again, I'll take log. So this will become ln of ln y square is equal to x. So this will be 2 times ln of y. Oh, okay. We wanted half only. So instead of doing this way, we could directly have taken log here. So y is what? E to the power root of e power x. Because if you see this thing here, when I plug in x is equal to 0, I get here e power 0, which is 1. E power 0, which is 1. That means e only. And then when I plug in here 1, I get e to the power root e. So that means they might be the inverse of each other. So we are thinking of solving that way. So ln I have taken. So it will be root of e to the power x down. And then if I take one more log here directly, so ln of y will be equal to this half will come down, and then x half will be coming down, and then ln of e power x is simply x. That means now we have here, this is half here given. A second. I'm writing 2 times ln of y is equal to x. That means f inverse of x is equal to 2 times ln of x. So if I write it here, then I have here half of, so this 2 will get cancelled here. So that means if I have e to the power root of e power x, this is half here. So ln of x is nothing but the inverse of this. So which means if I take this thing, integral a to b f of x dx plus integral c to d f inverse of x dx, then we know this result is going to be bd minus ac, okay, which you can visualize through the graph directly. So let us say this is some function and this value is a. So this is going to be f of a, which I can call some c, and say I have this thing, say b, and this is going to be some f of d is equal to some f of b. So if I'm finding this area, okay, and then its inverse, that means this area also. So this area is nothing but this rectangle area of this rectangle minus area of this little rectangle. So the big rectangle is BD minus small rectangle is AC. So this thing we can apply. So that means from here I'm going to have only, this is integral 0 to 1 f of x dx, and this half will cancel that half, that 2. So this will be e to e root e, f inverse. So I'm going to get only e to the power root of e. So the answer will be e to the power root of e. Yeah, we'll go for the next one. So the next question is, a variable plane cut off intercept from the coordinate axis which are equal to the roots of this equation. Then we need to find the locus of perpendicular from the origin to this plane. So that means if we have, so if we have, so this is my 3D system. So I have a plane which cuts off the intercepts here like this. So this is the 3D part here, and then from origin to this point. So this is the foot of perpendicular from origin to this. So this is the 3D plane like this, and I'm projecting it. So in case if you want to see the zoomed view, you can have it this way. Suppose this is my plane here like this. Then I want the foot, locus of the foot of perpendicular like this. So I want this thing. And here the intercepts from the coordinate axis which are equal to the roots of this equation. That means I'll take the equation of plane first. So let the equation of plane be, x by a plus y by b plus z by c is equal to 1. This is my plane. Now this point will be what? It cuts off the intercepts. So that means we need the coordinate axis. So here this is going to be what? A 0, 0 on x, and on y it's going to be 0, b 0, and on z I'm going to have 0, 0, c. This is my plane. These are my coordinates. So a, b, c are the roots of this equation. So a, b, c are the roots of this equation, which is x cube plus qx square plus 5x minus p is equal to 0, and p and q are the real numbers. So let's go ahead, and now we need the locus of foot of perpendicular. So let p h comma k comma t be the locus of foot of perpendicular. So this be the locus of foot of perpendicular from the origin. So let us find out the foot of perpendicular. So foot of perpendicular will be h minus origin is 0 here. So this over 1 over a, and this is equal to k minus 0 over 1 over b is equal to t minus 0 over 1 over c is equal to 0, 0, 0 minus of 1 over a square plus 1 over b square plus 1 over c square. This is what I get. Now let's find out hkt total. So h will be equal to, from here, this is going to be, from here h will be, so this part will be with h and this part will be taken there. So I'm going to have here, not h is equal to, it will be h into. So h into 1 over a square plus 1 over b square plus 1 over c square is equal to minus 1 by a. This is being taken here and 1 over a there. So here the constant term is p, and here k and q are real numbers. That means we have to make sure that none of them are 0. So plane should not pass through the origin. That information must be supplied in this question. And then k into the same story, 1 over a square plus 1 over b square plus 1 over c square is equal to minus 1 over b, and t into again 1 over a square plus 1 over square plus 1 over c square is equal to minus 1 over c. So the best idea that comes to our mind is we can square and then add. So I'm going to have here h square plus k square plus t square into 1 over a square plus 1 over b square plus 1 over c square, the whole square is equal to 1 over a square plus 1 over b square plus 1 over c square. So one of them gets cancelled. So I'm going to have here h square plus k square plus t square into 1 over a square plus 1 over b square plus 1 over c square is equal to 1. Now I'll call this equation star. So now we need to get the condition of ABC because we are finding the locus. So it must be free of ABC. So now let's go ahead. So since ABC are the roots of this equation, since ABC are the roots of, what's that plane? Plane. Where is this? X cube plus qx square. So x cube plus qx square plus 5x minus p. Minus p is equal to 0. So that means from their sum of roots, I get no information. From their product of roots also, I get no information because p and q we don't know. So the best part would be to use this sum. So plus minus plus. That means I'm going to have here AB plus BC plus CA is equal to 5. This information I have at least. So AB plus BC plus CA is 5. I'll call this. Uh, there's no point of calling it. Let's see now. Uh, hmm. So if I have this plane here, then the four top perpendicular. Okay, look at this four top perpendicular like this here. This is going to be HKT. So say this is point P and this is O. So if I see the DRS of OP, then DRS of OP is simply what? H, K, and T. But we know the DRS of plane, but the DRS of the plane is DRS of normal to the plane, basically. Even if you say DRS of the plane, it is understood. So DRS of the normal to the plane, it's going to be, not going to be, it's already here. This is DRS of the normal to the plane is 1 over A, 1 over B, 1 over C. Is 1 over A, 1 over B, 1 over C. That means these two DRS must be in proportion. Okay. That means they're ratios, like say H over 1 over A is equal to K over 1 over B is equal to T over 1 over C must be equal to some lambda. So from here, I'll find out now ABC because we need to remove them. So A is equal to what? Reciprocal and then lambda. So lambda by H and B is equal to lambda by K and C is equal to lambda by T. Now we can use this information here to get rid of ABC. So since AB plus BC plus CA is equal to 5, which means AB I can use it. So AB is what? Lambda square over HK and then plus. That means I'm going to have here lambda square into 1 over HK plus 1 over KT plus 1 over HT is equal to 5. So 1 by 5 is just simply 5 given. AB plus BC plus C is 5. Yeah, so we have used this thing. Now, this thing is equal to 5 we have got. Now from here, I'll try to find out HK, KT, and HT. And let's see what do we get. So in this case, what I'll be having, lambda square will be what? No, there is no point. What do I need basically? I need yeah, h square, k square, t square. I have 1 over a square, 1 over b square, 1 over c square. I want this one basically. So to get this one, what we can do is 1 over hk I have. Okay. Let's use this one only. So can I write down 1 over a square plus 1 over b square plus 1 over c square is equal to, I can write down here 1 over h square plus k square plus t square. This can be written. This not working. No, this won't work. We have one more thing. We can also have this thing from here itself. Let's just click on here. So if I try to find out h square plus k square plus t square from here, or let's say 1 over a square, I'll find out from here itself. So 1 over a square plus 1 over b square plus 1 over c square will be equal to, just take the reciprocal and add them. So we get h square plus k square plus t square by lambda square. So that means now we have got this thing is equal to, also I'll just, there's no point of writing this thing. We have got it. So 1 over a square plus b square plus c square, we already had managed to get it. So which means if I have this equation, so from 1, let's remove this. So from 1, we have 1 is this equation. Yes, h square plus k square plus t square. So h square plus k square plus t square into 1 over a square plus 1 over b square plus 1 over c square is equal to, is given to be 1. And now we have found that this thing is equal to h square plus k square plus t square into, this thing is nothing but h square plus k square plus t square by lambda square. So h square plus k square plus t square by lambda square is equal to 1. That means I can just plug in lambda from here, lambda square from here. So I get h square plus k square plus t square, the whole square into lambda square. If I take it here, so I'm going to get 1 over hk plus 1 over kt plus 1 over ht is equal to this phi. I'll take it to that side. So this gives me the final locus. So this is the locus of foot of perpendicular. Foot of perpendicular. Thank you so much. We'll see you in the next session.